So, um, so I'm going to do a video and focus on the objects I'm holding. So this is a little bit of information on volume so that you can understand more about how to find the volume of different figures. Okay, so here we have a box, Melanie referred to it as a box. And it's to find the volume of it, you're going to take the length times the width. So when you do that, you're finding like the area of this rectangle, okay? Then think about having a bunch of rectangles stacked up, and then you're going to multiply by the height, whatever that measurement is, and that's going to tell you then the volume of the box, or how much the box can hold. So if you look inside, how much can that be, how many cubic feet or cubic inches of the volume that we can put in that box, okay? So that's how you find the volume of what we call a rectangular solid or a rectangular prism, box, swimming pool, something like that, okay? Now, when we do these figures that we're going to do, it's important that the sides, that the height is straight. So like the height is always the same as we move around this box, okay? All right, so now we'll go to what we call a cylinder, something like a can, okay? So what we do is the can on the top and the bottom is a circle, right? Okay, so it's a circle. So you're going to find the area of the circle, and then notice these sides are straight, like all around the circle. They're not angled, they're just straight down, right? Okay, so it's like you have a bunch of circles stacked up, and so you're going to find the area of the circle, which we have the formula for the area of a circle, and then you're going to multiply by the height. So it's pi r squared, that's the area of the circle, times the height. I'm not going to give you all the formulas. Okay, so to illustrate this a little bit, think of having like a stack of Oreos, okay? So they're all stacked up. Each Oreo is a circle, right? So then it's like you have all of those circles stacked up. So you find the area of the circle, and then you multiply by the height, okay? All right, we can do this with other figures too. So here we have a box that has a base that's a triangle. So again, when we turn the box this way, all of these distances for the height are the same all the way around the triangle, okay? So you're finding the area of the triangle, then it's like having a bunch of triangles stacked up, and you're multiplying by the height, okay? So there you go. Could do that with a shape like this. We look at the bottom, it's an ellipse, what we call an ellipse, and your book mentions an elliptical tank. So they're saying like the base is an ellipse, but then these sides, this isn't a great figure, but pretend like these are all the same height all the way around. And so then you're going to find the area of that ellipse and multiply by the height. And that's going to give you the volume of an elliptical tank, which you may have that's holding water, something like that in the fire thing. You could do this with any shape. So this is actually a bread mold, okay? So not like in moldy bread, but like a shape. So the end is a heart. So if you notice though, when I tip it up, all these sides are straight down. So if I needed to find the volume of this, pretend like it had a bottom and it's a container, I'd find the area of the heart, and then I'd multiply by that height, because it'd be like a bunch of hearts stacked on top of each other. Okay, so hopefully that explains a little bit about volume and different containers you might have, and how that works to find the volume of those containers. Okay, have a great day.